Okay, so what we're going to talk about today is the area between two curves. But before we get started, what we've focused on up to this point is the area under the curve and the x-axis. Okay, and remember, if the area was below, then the area would be considered negative. If it was above the x-axis, then it would be positive. And if you had a combination, then the sign of your area, whether positive or negative, would depend upon how much is above versus how much is below. So it depends on the amount above versus below. Okay, so now what we're going to talk about is the area between two curves. So you're going to have two functions that you're dealing with. And today what we're going to focus on is just with respect to x, when the functions are with respect to x, and in the next class we'll focus on when that changes and when it's with respect to y. Okay, so when you have the area between two curves, you have to be given two different functions. And the biggest thing here is, again, you have to know that f and g are continuous functions on a closed interval. And what this is saying here is that one function must be greater than another on this closed interval. So what they have here is that f of x is just greater than g of x, meaning this function will be above g of x. Okay, so that's what it says here. This means that this given curve f of x will lie above the curve g of x, and you need to remember that the two can touch, but they can't cross each other. So what we're going to do is find the area indicated by letter A of the region bounded by the given function f of x, and on the top, and then below by g of x. And then here you have your bounds. So this is what we've got. We've got our boundary from A to B, okay, and then they give us our function f of x, which is what we're just calling it on the top. Now it can be any function that you want, but they named it f of x. So here, this is our function f of x on the top, and then we have our function g of x, which is our lower function on the bottom. So here you have a top and a bottom, and what we're looking at here in between A and B is this given area A. So you have to have a set bound, otherwise it goes on infinitely, and that's not how we're going to calculate the area here. So this is what we want to find, this area A. Okay, so conceptually what we can use is the idea of the Riemann sum, and if you look here, they have a series of rectangles from A to B, and they're actually using the midpoint theorem here, and this is delta x, and what they would do is conceptually use the sum of every single one, but we're not going to do it like that, we're way beyond, but this is conceptually what they're talking about, is the Riemann sum. Okay, so here they say that the area formula, if f and g are continuous functions over the closed interval from A to B, and if you basically have one function above another, meaning f of x is greater than g of x, top and bottom, okay, then the area of the region bounded by f of x on the top and g of x on the bottom, and you're given the line x equals a on the left and x equals b on the right, this is your area formula. So ideally what we have here is the area from A to B, so these are your bounds, okay, so that's what we're talking about here. Okay, and you have your top function f of x and your bottom function g of x. Okay, you're going to take the top area minus the bottom area, and then obviously dx, because you're integrating to find the area under the curve. So this is what we've got. If you have f of x minus g of x in terms of the Riemann sum or the area, this represents your height. Okay, and this dx, which will essentially get smaller and smaller for taking the limit as x approaches 0, this would represent your width. Okay, so this represents the vertical distance, This right here represents the horizontal distance. So here you're going to have the top, or excuse me, this represents your horizontal, this represents your vertical, but here this is your top minus your bottom. So whenever your formula is with respect to x, it's always going to be top minus bottom. So these are the steps on how to find the area between the two curves. So the first thing we want to do is sketch our graph. Sometimes you'll be given the graph, sometimes you're going to have to sketch it, and in today's notes there's a couple that you'll have to sketch. Okay, and then you're going to draw the vertical line segment through the region at some arbitrary point. We're not going to use the Riemann sum, so you don't have to do that, but you do need to have the enclosed area. Then what you would do is identify the top function, identify the bottom function, and this would be f of x minus g of x, whatever's on the top and whatever's on the bottom, and then you would integrate, and then you have to determine your limits. Sometimes they will be given to you and sometimes you'll have to find them, and I'll go through that, but this is the vertical line x equals a and x equals b. So here you have your lower bound and your upper bound. Here you have your function f of x and g of x, and this is what they were talking about in terms of the vertical line. The distance that we're looking for is from f of x to g of x. Okay, so you can clearly see what is on the top and what is on the bottom. And what they're doing is saying you're moving from A to B and finding this whole area in between here. So we want to find this whole area in between.